All right, here we go. We're going to do concept 1, roots and radicals. This first one we're going to simplify. When I see this, I always look for shortcuts in these because I'm lazy. I see a root 2 sitting right here, and I see 1 in the root 14. So I'm going to rewrite the root 14 as a root 2 times root 7. That's the root 14 times the other root 2 that's already there. Root 2 times root 2 is 2, and root 7 doesn't simplify. So my number 1 is done right there, 2 root 7. We'll pause right here. Number 2, we're trying to simplify this 4th root. So when I look at this, I see 3 different things going on. I see I got to deal with the 4th root of 81. I got to deal with the 4th root of x to the 20th. And I got to deal with the 4th root of x or y to the 16th. And so I'll just deal with each of those individually. The 4th root of 81, if I want to try to do a 4th root in my head on a number, what I'll do is I'll do the square root twice, so just back to back. So the square root of 81 is 9, and the square root of that is 3. So this just simplifies to 3. I could check that by taking 3 times 3 times 3 times 3 and making sure I get 81, and I would. The 4th root of 20, well, I asked myself how many times does 4 go into 20 evenly, and that would be 5 with none left over, so that's x to the 5th, times the 4th root of 16. How many times does 4 go into 16? That would be 4 with none left over. So my final answer here would be 3x to the 5th, y to the 4th. And that's all I need to do to simplify that. Questions on number 2. Number 3 then, we're doing cube roots. And again, I'm looking at this as 3 different parts. The cube root of 32 isn't going to go in evenly. Neither is the cube root of a to the 10th. But the cube root of b to the 15th will, so I have one of them that's not so bad. The cube root of 32, I need to find a perfect cube number that goes into 32. And if I go through my list of 1, 8, 27, I hit one at 8, so I'm going to use that. So I've got the cube root of 8 times the cube root of 4. That's the same as the cube root of 32. Why does that help me? Well, because the cube root of 8 is 2, and cube root 4 isn't going to simplify, times the cube root of a to the 10th. Well, 3 goes into 10 3 times with 1 left over. That means I'm going to bring out a to the 3rd. That's the 3 times it goes in evenly. And with 1 left over, I'm going to leave an a inside. Times the cube root of b to the 15th. Well, 3 goes into 15 5 times evenly with none left over. So my final answer here, everything that's on the outside is a 2, an a to the 3rd, a b to the 5th. Write all that down. And then I have a couple things inside a cube root for this final answer. I have a 4 and an a. And that's it for number 3. Any questions here? Number 4, what I did was I just went ahead and thought of, at least, this as one big cube root of 48 thirds, which is the same as the cube root of 16. From this point, I just need to find a perfect cube that goes into 16. That would be 8. So cube root 16 is the same as cube root 8 times cube root 2. The cube root of 8 is 2. So I get 2 cube root 2, and that's as far as I can take it. Any questions on number 4? 2 is binomial radical expressions. Number 5, we're just asked to simplify. So the key here is, is a root 7x a like term with the root 7x? And yes, they are. I have 2 of them plus 4 of them. That should equal 6 of those things. So it's 6 root 7x's. This root 7x doesn't simplify, so I'm just done right there for number 5. Any questions on number 5? Number 6 got a lot of you because you didn't think to simplify this root 4. When you simplify, you need to try to simplify as much as possible. So let's take this in pieces. I've got a negative root 2 minus a 5 root 2, or minus a 4 root 2 is a negative 5 root 2. But here I've got 3 times root 4. Well, 3 times root 4 is the same as 3 times 2. The square root of 4 is 2, and that's 6. So the final answer there should be 6 minus 5 root 2. Any questions there? 7, we're multiplying one radical binomial times another. For this, I'll just go ahead and FOIL. I'll take first 5 times 3 is 15. And then I'll do 5 times root 2, which is 5 root 2. And then I'll do negative root 2 times 3, which is negative 3 root 2. And finally, I'll do negative root 2 times positive root 2. That's going to be negative. Root 2 times root 2 is 2. Now I just need to clean up like terms. 15 minus 2 is 13. And 5 root 2's minus 3 root 2's should leave me 2 root 2's. And that's number 7. Any questions on number 7? A lot of people miss number 8 because they assume something that's not true. They assume they can just square the 4 and square the root 5. And that doesn't work. You got to ask yourself, what does it mean to square something? What does it mean to square something? You got to multiply it by itself. Like 5 squared is 5 times 5. 4 minus root 5 squared is 4 minus root 5 times 4 minus root 5. You have to multiply it by itself. So if we do that, we're actually going to end up foiling this together. 4 times 4 is 16. 4 times negative root 5 is negative 4 root 5. Negative root 5 times 4 is another negative 4 root 5. If you remember your special products, you can do this a little quicker. Negative root 5 times negative root 5 is positive. Root 5 times root 5 is just 5. And now it's just a matter of finding those like terms and putting them together. I got a 16 and I got a 5. Those are like terms. That's 21. I got negative 4 root 5's and another negative 4 root 5's. That's negative 8 root 5's. And that's done for number 8. Any questions on number 8? Concept was rational expressions. On number 9, we're multiplying 9 to the 1/2 times 9 to the 1/2. If you recognize this as root 9 times root 9, you're done. It's just 9. Okay? So that one's kind of a gimme if you recognize what's going on. If not, it's pretty tough. Number 10, 11, and 12 would have been tough for us this week because we haven't really done any of this. So let's... The way to deal with number 10 is to realize that this negative 2/3 power gets to the 8 and gets to the a. So let's go ahead and just split it right now. 8 to the negative 2/3 times a to the negative third also to the negative 2/3. There's a lot going on in this problem. Negative powers, all negative powers do is invert the number. They flip it over, basically. So instead of 8 to the negative 2/3, we could write that as 1 over 8 to the positive 2/3. That's all the negative exponent does, is it just moves the number across the fraction bar. So if I had this on the bottom, the negative would have moved it to the top. I have to evaluate that. When I raise a power to a power, this is the only time I get to multiply powers. The only time I get to multiply powers is when I raise a power to a power. So I can simplify that to a to the whatever negative 3 times negative 2/3 is, and that's going to be squared. Negative times negative is a positive. 3 times 2/3, the 3's reduce out, and it leaves me with the 2. Now I need to evaluate this 8 to the 2/3. And I tried to show you real quick how we can take the cube root of 8 and get 2, and then take that answer and square it, which would give us 4. So this whole thing just becomes 1 over 4 times a squared, which is the same as a squared over 4. And that's where I would have stopped right there. We'll pause right here and see if there's any questions. Number 11, they want us to write this in radical form. In other words, instead of doing a power the exponential way, they want us to write it with the root symbol. So what I need to see here is I need to see a 7th root of something. The key that a lot of you guys ran into trouble on this was of what? There's a big difference between this expression, which is what the problem is, and this expression, which is not what the problem is. And the expression on the right, the 10/7 works on the 10 and the x. And the problem, the 10/7 just works on the x. So nothing's going to happen to that 10. We're going to leave the 10 alone, and we're going to rewrite the x to the 10/7 as the 7th root of x to the 10th. So that's where we should have ended up on number 11. And the difference is what is the 10/7 working on? Is it working on the 10 and the x, or just the x? And in our case, it was just the x. Any questions on that one? This last one, number 12, if we rewrite it, might make it easier. It's the same as the cube root of 8, and then we have to raise it to the 4th power. I can put the 4 out here, or I can put it in here, but I can't put it both places. We're For this problem, I'm going to put it outside because the cube root of 8 is 2. And 2 to the 4th, if I think about it, I can do that in my head, right? Because these two 2's multiplied together makes 4. These two 2's multiplied together makes 4. And the 4 times 4 makes 16. So this whole thing should just be 16. Any questions there?